should independently do the translation of parameters from Unisim to Aspen and vice versa. I've seen so many problems with teams that towards the end of the project they find out, oh, we messed up the parameters. Okay? So several team members do it, so you minimize the chance of error.
Can you clarify how the Aspen parameters transmit?
I will do it. I will do number 3 from scratch. So until now, I just reviewed what we had done before. Say if you didn't have Aspen, I will start on the Aspen stuff right from the beginning. How many of you have Aspen installed now? Okay, I would say more than half of the class. If you have a very old computer with limited hard disk space, etc., probably you cannot install Aspen. I don't think, after all, you need 30 gigs. You have a question? No. Yeah, the hand rate went down again. Thank you so much. All right. But, so in that case, I've had one case where after a student managed to squeeze in Aspen, her computer became totally unusable and she had to redo everything. She had to reinstall operating system and everything. So, but I hope 80% of the class at least have it installed. And so for this portion of the homework, if you have not succeeded in installing Aspen, your computer doesn't allow you to install Aspen, I hope you have a friend and you can use her or his computer just for this part of the homework. Okay? So now, oh, by the way, we cut and pasted the parameters on an Excel file. You should have all the Excel file. This is mine. So I can be seeing it. And let's start asking. So, in my case, and with Windows 10, guys, I don't know, but in my case, it always bugs me that I cannot have an easy shortcut. And if you pin it, I have found it unreliable. So in my case, I put the programs I normally use down here. So Aspen and HYSYS, Unisim, and Python are down here. So I'll open Aspen 9. And the first thing,
so all we do from Aspen is get parameters, and that's it?
get diagrams. That's the main thing. And those diagrams are going to be critical for your separation design. Let me put it this way, without those diagrams, you probably will not succeed in doing it. Because if you have just two components as you draw, just 1 point. But when you have 3 components, then you have separation lines. And a lot of separations are impossible.
Oh. Okay.
You need to have those diagrams to see what separation is possible. Because if you specify an impossible separation, you can be trying for weeks to convert your columns, you will not succeed. All right. So we'll open a new case. So this should open up. Has everybody opened up Aspen who has Aspen installed?
It's opening right now.
Okay, let me wait a minute. Let me wait, that's why I asked. That is why I asked.
Ask him if he's going on a date. Ask him if he's going on a date.
Why would I ask him that? I know he got a haircut, but
What?
why would I ask him that?
Because he got a haircut.
It's more time for us than to open up.
It's the first time, so it's like I'm sure everything.
Is yours say database configuration?
There's another.
This is what's new in Aspen.
Once you start designing separation of the bases, it's got
Good.
Anybody else needs more time? Okay, let's get started. So click New Case. Select blank simulation. New case, blank simulation. All right, let me make it expand. And first of all, you see here a beacon.
Still thicker and fire bit. Still thinking.
All right, I'll wait. This computer is faster than my other computer, so
Oh, you got a new one? Nice.
actually I use that as a sample and the process.
Is that a new shirt too?
Buy a better one.
New shirt, haircut. Friday night.
Something tells me you can do a little better than gamer dining.
Put it more time. Blank. Blank simulation. Music. Yeah, blank simulation. Guys, I cannot hear Rolando if you're also talking. Say it again. Can you speak louder? Well, obviously you didn't select run Aspen Plus. You need to run Aspen Plus. Okay guys, we need to move on. So we're going to add our 3 components. So the way to do that, what I was saying before, you see a bigger properties and simulation. This toggles us between the two. You don't have to do what I'm doing now. Simulation takes us in the equivalent of the PFD screen. Properties takes us to the properties like in Unison. For this, we're going to be just staying on properties. We're not going to do any Aspen simulation in this class. Okay? But we need to put our parameters in, and the easiest way, at least for me, is to click Find. And then where it says Contains, type the name, so I'll type acetic acid, and click Find Now. Hopefully to find it. And you can see acetic acid is found. Okay, so I typed acetic acid, which is contains, and I clicked Find Now. And then I will select acetic acid and click Add Selected Compounds. Okay, everybody right? So clicking Add Selected Compounds. That adds your components. If I move this a little bit around, you'll see here acetic acid conventional and has filled out everything. If it has found it, it will have filled out everything. Next thing, diisopropyl ether. If I remember, typing diisopropyl is enough to find it. So I'm typing diisopropyl and I'm selecting Find Now. And here you will find diisopropyl ether, and again Add Selected Compound. So just type diisopropyl, and that was enough. It will ask you this annoying thing every time. Replace what you already have or add, select, add, and extra click. Finally, the last component we have is water. Again, click Find Now. And find our water, add selected compound. And again, instead of replace, add. At this point, you should be seeing 3 components, all conventional.
How do we delete components?
I believe if you click, you have the option.
Gotta restart your computer.
No, you don't.
Right click.
Let me say, first of all, close,
Restart Xbox.
Yeah.
You have to re-download your operating system.
then right click, delete row. Okay.
Uninstall.
All right, guys, please, let's get focused. All right. So we added our components, and you can see specifications, everything is in blue. If I scroll down, you see the next box is methods. That's where we choose our thermodynamic property package. So click where you see the red, and this window opens up, and here's where you choose what you're going to use. So the one pair, I can, with confidence, translate parameters correctly from Unisim to Aspen Plus and from Aspen Plus to Unisim is if I use general NRTL in Unisim and an RTL in Aspen. So we are going to select an RTL. Select all. I don't know why you got put that all.
It's under method name.
And here you'll find an RTL now. There are several RTLs, but let's just take the standard RTL. Okay. And if we click here, you can see that parameters is unselected. So click the arrow under methods, and you see everything else is in blue except parameters. Click parameters. All right. Double click parameters. You see there a menu that says binary coefficients. We have to select binary coefficients. That go too fast.
Can you scroll up a little?
So we're going to, let me try to make it so that I have a bit more space.
Yeah, can you maximize the screen?
Well, I don't want to lose the Excel that I have there, so that's why I don't want to maximize, but I want to make it all. Here you go. So you go, methods, follow the red, parameters follow the red, binary interaction. You can also press N, will normally guide you to the next thing to do. So if I press N, it takes me to binary interaction. Alternatively, you could click on it. And it actually automatically opens on the one that we need to set parameters, which is the NRTL 1, or you can click NRTL 1.
Did it automatically fill it in?
Yes, if you go with the arrows, automatically fills it in. Otherwise, and we'll put one pair of components, ether, water. And depending on the pair, you have different choices. Here I put some, not sure where those parameters are coming from, but if you click on the source, you see different choices. So this is good for merely vapor liquid equilibrium, ideal gas. And the first three are different vapor-liquid equilibrium with different model for the gas. And the last one is supposed to be optimal for liquid-liquid. But it doesn't matter because we're going to set our own parameters. We are going to put here the parameters that Unison has and see what is predicted with the parameters we put in Unison. Now, you see here you have AIJ, AJI, BIJ, BJI, CIJ, etc. Differences between Unison and Aspen. AIJs are AIJs also in Unison, but they are transposed. Normally you think I as the row, J as the column. And the so Bij would be row I, column J. But in Unison, that value should be placed in column I, row J. So what you see is Bij in Aspen is column J, sorry, column I, row J. Transposed. The column plays the role of I, and the row plays the role of J. So be careful. So AIJs in Aspen are AIJs in Unison. BIJs in Aspen are BIJs in Unison. Transpose both of them. The next one, CIJs in Aspen, are not the CIJs in Unison. I always have some students who don't pay attention and use the CIJs for Aspen as CIJs in Unison. No. The CIJs in Aspen are the alpha 1 IJs in Unison. And it's a symmetric matrix, so there is no need to transpose. Clear? Yes.
So the AIJs in Aspen are the AJIs in Unison? Okay.
So let's do the translation now. That's why I didn't want to shrink it. Let's put our parameter. The moment we change something, it will change to say user as the source. Right now the source is APV, VLE, ideal gas. So we have the pair. Let me go up a bit. The pair that we have here is I, the ether, and J is water. So let's make sure that we don't mess it up. I, ether, J, water. And B, so ether, water. So this is B ether water here. B ether water in Unison. Here's what we cut and pasted in Unison. So I'm saying ether first, water second here, right? Ether first, water second. So, but I will go here and I will take as row the water and as column the ether. So that Bij, which is 770 here, should be it was 993 in all Unison. So I'm going to cut and paste from Excel to Aspen. So control copy, highlight the 770, control V. Automatically, everything else, the other bit turned to 0, and now this source became user, and it took that back. The transpose of that, which is right here, ether water is 24.816. This will be the BJI. Everybody clear? So I will cut and paste the 24 to the BJI position.